All right, let's continue with section 1.3 and talk about frequency tables. All right, so once you have a set of unorganized raw data, you will need to organize it so that you can analyze how frequently each datum occurs. Yeah, datum is the singular of data. And then you want to be able to display it in meaningful ways and make interpretations and analysis. So raw data is just a list of a mess of data. We want to start to organize it. And so that's what we're going to talk about in a lot of the different sections in chapter 1 and 2. Okay. When calculating the frequency, you may need to round your answers and all kinds of different calculations with your data. You may need to round your answers so that they are as precise as possible. And a couple of simple rounding rules here is a simple way to round off final answers is to carry your final answer to one more decimal place than was present in the original data. So if your original data had whole numbers, it's good to go to one decimal place. Or if your original data had two decimal places, it's good to go to the nearest thousandth, which is the third decimal place, and so on. And then I highly recommend that you round off only the final answer. Okay, do not do any rounding off on any of the intermediate steps, okay, because then you could end up having round off errors and your answer will be off a little bit, and it can even be off by a lot. Okay, so if it becomes necessary to round off intermediate results, carry them to at least twice as many decimal places as the final answer. But what I recommend is just all of the decimal places that your calculator displays, use them all until the very end. Don't do any rounding until the very end. Okay, data can be organized by using tables, graphs, and numerical summaries. Again, we're going to be doing all that kind of good stuff in the next couple of chapters. Raw qualitative data comes as a list of values, where each value is one out of a set of categories. These values can be organized as either a long list or in a table. Interpreting the list of data can be difficult, particularly if there is a lot of data. So qualitative data values can be organized by a frequency distribution, and that's what we're going to study. I have a couple of examples of a frequency distribution. So a frequency distribution lists each category of data and the number of occurrences for each category of data. The frequencies are the counts of the occurrences for each category, okay? And we'll work one out from scratch in just a second. Cumulative frequency is the accumulation of the previous frequencies. A relative frequency is the ratio, okay, fraction or proportion, of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. And that sounds fancy. It pretty much just means you divide the frequency of any category by the total number of pieces of data. So you'll see that pretty clearly once we work out an example. And then the cumulative relative frequency is the accumulation of the previous relative frequencies. All right. Let's go ahead and do example 2 here. Let's consider the raw data below, which represents the number of siblings each person has from a random sample of 30 people. Okay, so there's the raw data. And like I say, raw data is kind of just all scattered around. It's not necessarily in order. It's not grouped or organized in any way. Let's construct a frequency and relative frequency distribution table for this data. We're going to use 2 decimal places when rounding if needed. All right, so I have the table already set up and titled for us, so we're just going to fill this in. Okay, so all of this data, this represents pretty much different categories of the number of siblings that a person has. So it looks like there's a lot of zeros, ones, twos, threes, and it looks like 4 is the highest. Okay, so those are going to be the number of siblings categories. Now you can't have a decimal of a sibling, right? Okay, so that's why we're just going to have single categories here, a category of 0, 1, 2, 3, and 4. Okay, so then what we want to do is we want to go through and just kind of tally up. The frequency is the first thing we want to do. And so we're going to go ahead and just find out how many zeros are there. Okay, that's really all we're doing here. And so I'm just going to go through and maybe cross them out as I count them up. So let's see, 1, 2, 3, 4, 5. So there's 5 of those. Okay, let's go through and do the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ones. All right, how many twos? 1, 2, 3, 4, 5, 6, 7 twos. Okay, how many threes? 1, 2, 3, 4 threes. And then how many fours? Looks like just that one datum left. That 4, there's 1. All right, so that's the frequency. So that tells us really quickly, it organizes the data really quickly. This tells us how many zeros, how many ones, how many twos, how many threes, and how many fours. So that's already a lot of organization. Now, the cumulative frequency, that just means it's whatever you're currently at plus all of the ones less than that. So all we have to do for cumulative frequency for the number of siblings, that just means how many are 0 or less. Well, there's nothing less than 0, so it's just going to be all of those 5s, all 5 of those. Okay, going up to the next one, it's all of the current category and everything less. So this would be 13 plus 5. And so it's 18 would go here. Okay, then the next one up, it's the current value plus everything less. So it would be 7 plus 18. Okay, so that's 25. Okay, then the next one, it's the current plus everything before it. So that's the 4 plus that 25. So that's going to be 29. And then the last one is the 1 plus everything before it. So it's just an accumulation. How many are equal to or less than that value? Okay, and so that's really actually pretty important, that number 30. If you didn't know what the number of data was, okay, they did tell us. Sometimes it's not told to us, so it's a little bit tricky, but I do want to make a note to myself that n equals 30, because we need that for the relative frequency. Now, the way it's described up here is a little bit awkward, the way it's talking about relative frequency. It's the ratio of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. All right, that's fancy for just saying, take your frequency and divide it by n, okay? And then there's a lot of different ways to present your data, and you should read the instructions for if it wants you to leave it as a fraction, or if it wants you to write it as a decimal, or if it wants you to write it as a percentage. I'm going to go ahead and use a percentage for these ones, but read the instructions very carefully when it's telling you how to do it. So for the relative frequency, you just want to do the number, the frequency, divided by the total amount of data in the entire set. Okay, so 5 divided by 30, and I want to write this as a percentage. So when I go 5 divided by 30 on my calculator, that's going to give me 0.1, and then there's endless 6s like this. But if I want to write this as a percent, multiply that by 100, and it's going to be 16 point, and then to round to 2 decimal places, right? It's wanting me to round to 2 decimal places, 16.67%. And I'm going to use that percent symbol to really indicate that I'm using percents here rather than the regular decimal from 5 divided by 30. Okay. Continuing with the relative frequency for this category where the number of siblings is 1, that's going to be 13 out of the 30. Okay, and I'm going to do that same process. I'm going to go 13 divided by 30, and then whatever that number is times 100 to turn it into a percent. And so I'm getting 43.33, and I'm going to use the percent symbol to really indicate I'm doing a percent. Okay, for this one, relative frequency, it's the frequency from that category divided by the total number of data points. So 7 divided by 30, and then times 100 to turn it into a percent, I'm getting 23.33%. Okay, for this one, the frequency divided by the total, 4 divided by 30, and then times 100, 13.33%. And then finally, it's going to be 1 divided by 30. All of these are the frequency divided by n. 1 divided by 30 and times 100. This is 3.33%. Okay, so those are the relative frequency, and that's another nice category that lets you know what percentage of the data falls within any one of those categories. And so we can see that the number of siblings of 1 is by far the highest at 43.33% of the data, almost half. Okay, and then cumulative relative frequency is very similar to the cumulative frequency, where it's just the current category plus all of the ones below it. So this first one is going to be the 16.67%. The next one is going to be the 43.33 plus the previous one. So I'm going to type that in, 43.33 plus 16.67, and that's exactly 60%. Okay, so it's the current category frequency, the current category relative frequency plus all of the previous ones. Okay, so then for this next one, it's going to be that 23.33 plus all of these previous ones, but all of those previous ones are already built into that, the 60% right there. So we can just say, and I'll write it off to the side here, it's going to be 23.33 plus 60. And for this one, what I did right here is I did 43.33 plus 16.67. So 23.33 plus 60, and we get 83.33%. Okay, for this one, it's going to be whatever the relative frequency was from that category. Whoops, it's going to be 13.33 plus all of the previous ones. But again, all of the previous ones are already built into the one I just did there. So plus the 83.33. So 13.33 plus 83.33, and I got 96.66%. And then the last one, it's going to be the current relative frequency right there, 3.33, plus all of the previous ones combined, but all of the previous ones combined was that 96. Okay, so plus adding those together there, and I got 99.99. Now that number should technically be 100%, but because we did a little bit of rounding to those 2 decimal places, that's why it came out to the 0.99. So that's totally acceptable for this situation. It's effectively 100% because that means how many of them or what percentage of all of these are 4 or less. And it's all of the data, 100% of it. Okay, I'll make a separate video to pick up on the last example.